This is a circuit of the LED diodes in the Panasonic that I did in the last video. It's simplified. I've taken a lot of the circuitry out of it just to show the basic elements. What we have here at the top here is our 26 volt going through this L7800, going down through these 5 LED diodes. What we need for these diodes to emit light is to bring the cathode end here down to ground, which really means we have to short that point out there to this point. Then it goes down through this current monitoring resistor and to ground to complete the circuit. When this switch is not connected to this point, to here and here, these LEDs will not emit any light. So on the cathode end we have this transistor, and on the base we have pulses, high at 1 volt and 0 volts then for off. When this waveform is high at 1 volt on this base of the transistor, this behaves like a switch, and this point here is connected directly here to this point here, and current will flow through these diodes. And then when current flows through them, you'll have a 3 volt drop across each one of these diodes, as these are the voltages that the diodes operate at. So we'd have a total of around 15 volts drop across it. You might not see that with your multimeter because at the end of the day this is a pulse width modulated signal here, and this will be switching on and off very quickly, and you will get an average value of that voltage at that particular point on the cathode, between the cathode and the collector of the transistor. Most likely in the TV itself, this here is an FET because they're better at being a switch, but the theory is the same. We'll just keep with the transistor. I have it drawn here for now. For me to test these diodes individually, as I said earlier, we need 3 volts to drop across each one of these. What I did was I put a power supply. I have a variable power supply bench one. I put the negative here and the positive here, and have the power supply set to 3 volts, and that will light up. And go to the next one, and then I came to one of them and it wouldn't light up, which was really telling me that diode was gone. Another way I'd done it as well, check a whole strip. I brought it up to about 15 volts and I put the negative here and the positive on the anode side, and gave it about 15, I'm sure it was 15 volts I gave it. And the on the good operating strips, LED strips, we had the LEDs lighting. On the faulty one we got nothing lighting. I could only light up each individual LED until I came to the faulty one, which did not light up. Also, I noticed when I was on the faulty leg and I had my multimeter positive probe here and the negative lead connected to ground, when the LED circuit shut down, which would have meant this would have been going up here for a while when you got that LED flash, and then it would have went to a straight 0, which would have brought this to a high. It should be at 26 volts, the same value there briefly, until the whole lot shuts down. The 26 volt line itself will shut down. But what I got there was about 3 volts, which wasn't right. The working legs, when this switched off at this point here, when the base of the transistor went to 0, the collector went to about 26 volts, thereabouts. It gave a voltage anyway. Also in most LEDs there is some kind of current monitoring done as well, and that is most likely done inside the chip itself. I can't tell, I didn't get a data sheet on it, but it consists of possibly 0.1 ohm resistor, something around that value. It'd be a low value anyway, and connected to ground, and then what the voltage drop across that resistor would be proportional to the amount of current going through it. If one of these diodes went short circuit, you'd be taking one of them out of the loop, and which would mean you would have a higher voltage. We need, on this particular branch, we need 15 volts. When one of these go here, we don't need 15. You can take 3 off that, which would give you 12. So now they would operate under 12 volts, but it's actually getting 15 volts, which would mean they glow brighter and they will get hotter. So we have to have some kind of overcurrent protection in them to stop them burning out. We also have over voltage protection somewhere on the power supply, but I've never had much problem with the over voltage protection in LED circuits yet. Maybe someone else has. I'm sure someone in the comments section will say different. Hope that helps. Thanks for watching.